Okay, so yesterday you learned, given the angle, how to find the sine or the cosine and the other four trig functions. Today, it's the other direction. You're going to be given an answer to sine theta, and you're going to figure out the angles who have that value of sine. And there are actually an infinite number of answers. So when you look at the example problems, if this will stop lagging. There we go. The example problems are telling you to use the unit circle to solve each equation for theta, but only over the interval 0 to 360. And I want to emphasize 0 is included as a possible answer. 360 degrees is not. That way, every single point on the unit circle represents only one angle instead of every single point on the unit circle representing an infinite number of angles for however many times you go round and round and round and round and round and land at that spot as the angles keep going. So, starting at the top, if you are working with sine theta or its reciprocal function, who is sine's reciprocal function? Let me see in chat. Who is sine's reciprocal function? Good, cosecant. If you are trying to find the angles for either of those two, draw a horizontal line. So basically, I've got a horizontal line here waiting to show you. If I told you that sine theta was equal to 1/2, you're going to want to remember that on this unit circle, you have all of these y coordinates. You only know what's going on exactly for y equals -1. And let me get my highlighter. For y equals -1, for y equals -√3/2, -√2/2, -1/2, 0, 1/2, √2/2, √3/2, and 1. You can only use the unit circle for those specific numbers. Any other number, you need a calculator or you're approximating. So you're going to be told that the sine of theta is equal to some number. And what you want to do is take a horizontal line and draw the line y equals that particular number, whatever that number is. And that will show you that that horizontal line, y equals number, intersects the unit circle most of the time in two places. And the angles that land you on those spots are the angles that are the answers. Now, I do want to say, though, that you might get a horizontal line y equals -1. What angle will give you an answer of the sine is equal to -1? So that was a question. What angle will give you sine theta equals -1? So this horizontal line down here at y equals -1. What angle does that intersect? So this angle right here. There you go, 270. What I want you to realize is if the answer to sine theta is in between -1 and 1, you will have two answers. If your sine theta is equal to +1 or -1, you only have one answer for each round through the circle. If you get a sine equal to something bigger than 1, it doesn't intersect the circle. or smaller than -1, it doesn't intersect the circle, and that's where you would have no solution. So what we're going to do is we're going to move over here and try number 1 and then also try number 2. So what I want you to do is draw a horizontal line at y equals -√2/2. -√2/2 is the middle of the special 3 numbers on the negative y-axis. And if you draw a horizontal line, that horizontal line crosses the circle in 2 places. That means that anytime you have a terminal side of an angle land, and with a terminal side of an angle, it starts at 0 degrees. And if you turn this much, the terminal side will intersect the unit circle. And Lombari, you're unmuted. Yeah, there we go. More feedback. So when the terminal side crosses the unit circle at that point, that is one of the angles that have a value of sine that is -√2/2. So what angle is this one right here? $225? Because it's 180 plus another 45 degrees. Jump and jump. And that takes you to 225. Now, also on a first round through the unit circle, you have a terminal side of an angle crossing through the unit circle where it has a y value of -√2/2. That means that this angle is another angle whose sine value is -√2/2. So what is that angle? I think it's easiest if you, there you go. For this angle, I find it easiest if I think about this being 360 and subtract 45 degrees, because that halfway cut is a 45-degree angle, half of a quadrant. So 315 degrees. Now, I want you to understand that I can go round and round the circle. So these 2 angles are just 2 angles of many who have a sine value of -√2/2. I could keep going around and around and around and around and around. And every time I get to a coterminal angle to one of these 2, I have another answer for that equation. So I'm giving you the instructions of just finding the angles that are in the first round, because if you know all the angles that make a first round around the circle, to find anything else, you're just finding coterminal angles and you're adding 360 or subtracting 360 any number of times that you need to. Now, are you ready for cosecant? No? Okay, but we're going to do it together. You're not on your own. Who is cosecant's reciprocal again? Mm-hmm. And what number is the reciprocal of negative 2? I almost said the answer. Right. Now, you can do this in several steps or just do it instantly. Instantly would be you say reciprocal of cosecant is sine, reciprocal of negative 2 is negative 1 over 2. If you need to do it more slowly, then what I would say is start with changing cosecant theta to being 1 divided by sine theta. Then you have an equation, but you have sine in your denominator. If you multiply sine theta to both sides, sine theta is no longer in the denominator. And then you can figure out what sine theta is equal to if you divide by negative 2. So whether you can see the answer quickly or it takes you writing down a lot to get there, you're then ready to use sine instead of cosecant. You're going to draw a horizontal line where y is equal to negative 1/2. And so draw that line. There are 2 places that it crosses the unit circle. And you're trying to figure out which angles have a terminal side that cross through those 2. I'm going to draw an initial side so that I can show you one of those angles and the other angle. So how many degrees do I go through to get to this spot? Mm-hmm. Good. And if some of you aren't seeing it, you want to remember that this is 180 degrees. And this cut right here is going 1/3 of the way through a quadrant, so that's 30 degrees farther than 180. So if I add 30 to 180, I get 210. This angle over here is 30 degrees before hitting 360. So 360 minus 30 gives me 330 degrees. Or I can go crazy with the threes. And that gives me 2 angles, the only 2 angles that are in between 0 and 360, for which the cosecant of the angle is equal to negative 2. This isn't too bad, is it? Yeah, it takes time to get used to. And we're going to keep doing this over and over again to get you more comfortable. Next, who is cosine's reciprocal? If you have cosine theta or secant theta, draw vertical lines. Vertical lines when I'm dealing with cosine or secant. So with cosine being equal to negative 1/2, you are looking at cosine represents an x coordinate. So you're drawing the line x equals negative 1/2. which would be this vertical line right here. Your job is to state which angles these two are. So I'm going to draw an initial side where 0 degrees is. And then I'm going to show from that initial side to this terminal side, I have an angle that crosses the unit circle right there. What is that angle? Oh, you're already telling me. Just trying to live a little. Well, I can't accept that in the classroom. So this would be 90 degrees plus 30 degrees more, which is 120 degrees. Then if it's okay, I'm going to go ahead and draw the other angle in here to show you that there are two of them. The one that sweeps further out to here, what angle is that? 240. And what you can do is start at 270 and subtract 30 degrees. Or you can start at 180 and add 60 degrees, whichever you like. But those are the two answers. And that is number 3 done. Number 4, who is secant's reciprocal? When drawing these, do we need to add the little swirl? No, you don't have to. In fact, when you're drawing these, you're drawing it for yourself to understand what is going on. Because eventually you're going to reach the point where all you do is write the answers down. That's the point of using the unit circle to solve things, is to be able to just draw whatever you need to draw to see it and then answer. So cosine, and what is the reciprocal of 1/2? Two. So what that's saying is draw a vertical line at x equals 2. But if I look at where the x-axis is, here's 0, here's 1, here's -1, 2 is over here. So if I'm drawing a vertical line at x equals 2, it doesn't cross the unit circle. And what does that mean the answer is? Did I make a mistake on the answer key? Okay, I'll get to that. So what is the answer to this one? The better, well, if you're answering what is the solution, you would say no solution, but yeah, undefined. On a test, if someone read undefined, I would accept it. Okay, now, tangent and cotangent are not as easy. But if you listen carefully, I can teach you how to work with them. Yes, you can use NA, not applicable. Basically, I'll accept anything that basically says, you know. Now, tangent's reciprocal function is cotangent. When you are working with tangent or cotangent, you want to draw a line through the origin. we can painstakingly go through and look at what the value of tangent is at each of these angles. I don't want to, I want to make sure that you understand what the numbers are, but I don't want to go so far that you've got it and I'm just being redundant. So let me know when I'm reaching the point of being redundant. I'm actually going to start with this one right here. Tangent is sine over cosine. When you are at a 45-degree angle, sine and cosine are the same exact answer, right? When you are at 45 degrees, your tangent is actually equal to 1. Now, if I draw a line through the origin and I come over to the other side, sine and cosine are both negative root 2 over 2. So what does that mean? The tangent is at that point also tangent theta is also equal to 1 at that point. So that's 45 degrees and which one was that? 225. Now, I'm going to come over here to this angle. When I'm halfway through quadrant 2, my sine is positive root 2 over 2. My cosine is negative root 2 over 2. What is the tangent of theta at that angle? Good, negative 1. Then I'm going to erase the actually, no, I'm going to hold on to that, but I'll erase before the next. Well, tell me if it gets too crowded. Okay. If I draw a line through the origin straight across the circle, again, tangent is sine divided by cosine. Sine is negative root 2 over, negative root 2 over 2. Cosine is positive root 2 over 2. What is the value of tangent? You got it, negative 1. So what you are beginning to see is that when you are on opposite sides of the unit circle, the tangent has the same exact answer. I also want to help you to see that the value of tangent is also always the same as the slope of the line through that origin. Next, I'm going to draw through the origin a horizontal line. This point right here is x coordinate 1, y coordinate 0. Sine represents the y, cosine is the x, tangent is sine over cosine. What is 0 divided by 1? What number is 0 divided by 1?
0.
Yeah. So when you are at 0 degrees, 360, negative 360, all the coterminal angles there, the tangent of that angle is 0. And if you go over to the other side, or whoops, negative 1, 0, the sine over the cosine, or the y over the x, is 0 over negative 1, and the tangent is 0 there as well. And then I'm going to draw one more line before talking about it and then erasing these and doing the others. So you can probably guess I'm drawing a vertical line. For these points, the one at the bottom is 0, negative 1. The one at the top is 0, 1. If I'm looking at tangent, tangent is the y-coordinate over the x-coordinate. For this bottom angle down here, what is the answer to negative 1 divided by 0? Okay, let's not be concerned about Subman, and thank you, Lucas. Yes, it's NA, it does not exist. Tangent is undefined at 270. And it is also undefined at 90 degrees. Now, before I erase this, I want you to step back a little bit. And I'm going to keep telling you this. With tangent being sine over cosine, which is y over x, and I'm dealing with a line that goes through 0, 0. Tangent theta and the slope of that line are identical. So look at the 4 lines. This blue one, that is a slope of 1. This green one is a slope of negative 1. This red line is a slope of 0. And this black line is where slope is undefined. In between, as I go from 0 degrees to 45 degrees, my tangent is going to go from 0 to 1. As I go from 45 degrees to 90 degrees, my tangent is going to go all the way from 1 to getting bigger and bigger and bigger and bigger. I could go to a slope of 1,000,000 and 1,000,000,000 and 1,000,000,000,000 and keep going. And we can continue to look at all of that symmetry as we go along. But let me point out to you that if you draw a line through the origin, it has a positive slope if you are in quadrants 1 and 3. It has a negative slope if you are in quadrants 2 and 4. And I want to add on that cotangent is tangent's reciprocal. So if you can figure out how to use tangent, you can use cotangent also. I'm going to erase this, and then we're going to look at 2 more very important numbers. We have looked at all the angles except for the ones that are a third and 2/3 of the way through quadrants. So I'm going to start with this one. At 30 degrees, sine is positive 1/2. Cosine is positive √3/2. So I'm going to write down tangent of 30 is equal to sine 30 over cosine 30. And then do you see that the divided by 2's can cancel each other out? And I get 1 divided by √3. I'm going to leave it there. And then we're going to look at 60 degrees. For 60 degrees, the sine is √3/2. The cosine is 1/2. And you can cancel the over 2's to get √3/1, which is √3. Now take a good look at these two numbers, √3 and 1 divided by √3. If I asked you to draw a line with a slope of √3, would you draw a line that is steeper than a 45-degree angle? If I draw a line at a 45-degree angle that has a slope of 1, if a line has a larger positive slope, it's steeper. And yeah, we don't have a quiz today. For example, if I asked you to draw a slope of 2, would you draw something steeper than something that has a slope of 1? When it comes to the only angles we look at in a unit circle, if I focus on quadrant 1 for a moment, there are only 3 angles in quadrant 1 that you have to be ready to deal with. This angle has a slope of 1. The other 2 angles have a slope of either √3/1 or 1 divided by √3. √3 is bigger than 1. It has a steeper slope. One divided by √3 is between 0 and 1. That's going to give you a slope that is not as steep as a slope of 1. And when it comes to the unit circle, there are only 3 angles you're expected to deal with when it comes to quadrant 1. And the slopes of those 3 angles are these 3 numbers. If you extend these lines to the other side of the circle, you don't change the slope of that line. So I want to say again, all you have to remember is you have a slope of 1 and then 2 slopes that involve root 3. If it's root 3 over 1, you're looking at a number bigger than 1, so it's steeper. If it's 1 over root 3, it's a less steep line because 1 over root 3 is between 0 and 1. Then you have their mirror images on the other side, and all they are the same numbers but negative slopes. So I'm going to erase these. And then I'm going to draw the line that has a slope of -1. Now this blue line that I'm drawing right now, is it steeper or less steep? Is that slope negative root 3 or negative 1 over root 3? It's going to be the slope with the bigger, with the root 3. And you don't have to do things this way. You could look at every single time you want to do tangent, you could ask what is the sine divided by the cosine. The sine is negative root 3 over 2. The cosine is 1 over 2. The over 2's cancel, and you get negative root 3. And then lastly, this is going to be where your tangent is negative 1 divided by root 3. And that goes for both sides. Now, let's try these two problems. For number 5, I threw out there root 3 over 3. Because I want you to realize that that is one of the special numbers I just talked about. It just looks differently. I can see the other version of this if I multiply numerator and denominator by the square root that I see in the numerator. When I multiply across the top, root 3 times root 3 gives me just 3. In the denominator, I have 3 times the square root of 3, and these 3's cancel. If you're familiar with the slopes and where they are, this can be faster. The old-fashioned way of doing this is that you have to change tangent into a ratio of sine over cosine where it actually takes you to one particular point. And the only way to do that is if you bring in a divided by 2 to both numerator and denominator, and then look at where is the sine equal to positive 1/2, where is the cosine equal to root 3 over 2, and look for the angle where that happens. Additionally, if these are both negative, I will get the angle on the other side of the unit circle. So if sine is negative 1/2, that would be down here. If the cosine is negative √3/2, that would be over here, and that takes us to this angle. So I try to push the issue of slope because it takes far less time than what I just talked you through of, first of all, you have to realize that √3/3 can be written as 1/√3, and then you've got to bring in a divided by 2 and know that you need to bring in a divided by 2. And then not only that, you have to realize that not only can both of them be positive, they can both be negative. And it's just, it's a bit much. If you remember tangent as slope, then when you realize that √3/3 is the same thing as 1/√3, you can see that this is first positive. So that means it's one of these 3 lines. It's not 1. So it's either this line or this line. And if you need to, you can play with the sine and cosine to figure out which one is which. And yes, because class goes until 1:50 today. The steeper line is the √3. The less steep is the one divided by √3. So that means that the correct pair of angles are found through the line that goes through the origin with the less steep slope that is positive. And that gives you 30 degrees and 180 plus 30, 210 degrees. You got it. Okay. For cotangent, cotangent is tangent's reciprocal. The reciprocal of 0 would be asking what's 1 divided by 0. So what is 1 divided by 0 giving you? One divided by 0. There are different ways that you can go about this. You have to find the way that works for you. So we've got 5 minutes left. Let me tell you, I'm going to finish the way I'm approaching it, and then I'm going to show you other ways you can approach it, and it's up to you how you want to do it. 1 divided by 0 is undefined. Where does tangent have the undefined slope? (90 degrees and 270 degrees. And then you're done. Now, another way that you could have approached this was, remember that cotangent is cosine divided by sine. If a fraction is equal to 0, its numerator has to be 0. So this equation quickly turns into cosine theta being equal to 0, which means you're looking at when is x equal to 0, and you draw a vertical line x equals 0, and you run into those angles. So that's another approach you can take. I got the 1/0 because what I did was I looked at cotangent's reciprocal as tangent. 0's reciprocal is 1 over 0. When you reciprocate something, you put it underneath of a 0. Yeah. So what I do is I look at cotangent and think its reciprocal is tangent. And then I look at 0 and think its reciprocal is undefined. And tangent has an undefined slope at these 2 points. And what I find to be easiest is if for secant, cosecant, and cotangent, if for those functions I turn them into their reciprocal, I only have to know how to deal with 3 functions instead of 6. And that saves me a lot. Now, there are some additional examples, and I wasn't quite sure if we'd have enough time. The answers are available to you, but Jason, you said that I had which one was incorrect on the answer key? Do you know which one?
I think 7B would be wrong.
Let me see. Oh. I drew it in the wrong spot. Oh, I know exactly what I did. I had a dyslexic moment, I suppose. I was thinking 0. It doesn't matter what I was thinking. So sine is y. Y equals 1 is a line up on top here. And that only touches the unit circle in one spot, and that's 90 degrees. So I'll have to fix that on the answer key. These additional examples are for you to look at and make sure. Did I just mess up? Oh my goodness. Did I mess up more? Yes, I did, because I failed to add, and this should be 300. Thank you. Was there anything you noticed that I might have messed up on? I'll have to double check them and make sure. So what you can do is you can look at this answer key with the classwork to make sure that you're understanding how to work with these problems correctly before turning to the homework. And you don't want to leave this for Sunday night. You will have forgotten how to do this by then. I really, really, really recommend that you actually do this tonight. And class is over. I can't hold you any longer. Farewell.